We have 1 more minute. Fifteen seconds. Okay, that's time. Yeah, so no more writing answers on the quiz at all. In class, we're going to go over it, grade it in class, go over the answers in class. You'll grade your own quizzes. You don't have to switch with anybody. There's a number of reasons why we're doing the self-grading in class. But the main one is that my experience is that it helps students, you get the immediate feedback on what you got correct or incorrect, and you can ask questions as we're going over it about why the answer is a certain way. So I think it's a good study tool to be able to understand what's going on. And especially in the subsequent quizzes related to Python, things build off of each other so much that you really basically need to have a perfect understanding of all the previous quizzes in order to be progressing with the course. So I think this helps us make sure that we all have a good understanding. As you are grading your own quiz, obviously you are not allowed to modify your previous answers at all, and I trust you all to be adults about that and not cheat, not modify your own answers. I don't think, certainly on these first few quizzes, there's no incentive to cheat because if you recall from the syllabus that the first 2 quizzes, if you don't like your grade for whatever reason, you can retake it. You just have to come up to my office within a week from a quiz date and you can come and retake it. And then whatever your score is on the retaken quiz will be your score on that I enter into Sakai. So there's no incentives to cheat. And I will also mention that last year I did have to refer somebody to the honor council for this class. And I hope I don't have to do that again. Any questions about anything administrative related to the quiz before we get started with going over the answers? Okay. So I have open the PDF right here, which is just what you have exactly in front of you. And I also have opened up the HTML file inside of VS Code. And this is the exact same HTML file that you had for this quiz. It also happens to be the exact same HTML file that you used on the practice 2 quiz. That should look familiar if you did that. And then what I'm going to do is, just like we did in class before, in order to figure out what are the answers to all these questions, I'm actually just going to type them in here and see how it affects our results style /style like that. Save it. Let's come back over here. I have it already loaded up in Firefox. And there we go. So the first problem, p space dot bold. P space dot bold like that. The selector again is whatever comes to the left of the curly braces, and then we'll set the background color to red, not RD red, like that, and make sure I save it. So p space dot bold. First, we're going to have to find all of the p tags. There are 2 of the p tags, and then we're going to find all of the tags inside of the p tag that have the class dot bold. Come back over here. F5 refresh, and you can see that nothing got selected at all. So the answer for number 1 is 0. The quiz is out of 5 points. Each problem is worth 1 point. So each one of these numbers that you get correct, you'll get a point for. Each one that you get incorrect, you will not get a point for it. So again, this dot bold had to be a child or an ancestor somehow of the P tag. And here the P tag itself is bold, but it has no children at all, has no ancestors. If we wanted to select the P tag, I would have to remove that space right there, and then it would be selecting that P tag. Any questions about this first problem? Okay, number 2, hashtag body space IMG. Hashtag body space IMG. This one might look familiar. Come back over here, F5, and highlighting this image down here in red, but not this image up here in red. Question is why? Well, the hashtag body doesn't, here we have a body tag, but the hashtag in front of it means that we're looking for the IDs and not the tags themselves. So even though there's an image right here that is a descendant of this body, we never select this body tag. This div tag, though, does get selected by this hashtag body because its ID is body. And inside of this div tag, there's this one image tag down here. So this image tag got selected and the red background got applied. Any questions? I guess I should write out the answer up here. 1. Any questions on problem number 2? Number 3, H2 plus P. H2 plus P, save that. Come back over here, refresh, and here's the one paragraph that's getting selected. So the H2 tag, again, selected here, the plus, only the very next sibling, so this P tag here, not this P tag here. Actually, now that I'm looking at this one seems like it might have also been on the practice quiz too, I'm not sure. So we got a 1 for number 3 as well. Number 4, body tilde div. BODY tilde div. So we have a body tag right here. The tilde means that let's find siblings that are div tags. Does the body tag have any siblings that are div tags? And the answer is no. It has children and various sorts of descendants that are div tags, but it has no siblings that are div tags. So number 4, the answer was 0. Any questions so far? Okay, very last one, body space li greater than dot bold. Body space li greater than dot bold, like this. So we find the body tags. There's a body tag, only look inside the body tag for li tags. There's these li tags down here. All of the li tags happen to be inside the body tag, so that doesn't really affect things. Find the li tag. Now we need to look for the children that are dot bold. Here we have one child dot bold. These things have the dot bold class, but they are applied to the li. So let's come back over to Firefox, F5, refresh, and only this image down here gets selected. These other ones do not get to select it, so the answer is 1. Any questions about any of the quiz problems? Anything at all about the quiz? Go ahead and total up your score, put it at the top, and somehow get the papers up here to the front. All I need is the first page that has the problems and the score. Whatever. Either way, doesn't matter. Bro, I literally I don't know. Any other quizzes that I don't have at this point? Okay, let's bring it back together. Today in class, we're going to be continuing going over the next practice quiz. This one focused on Python. So I recommend getting that sheet of paper out, that big stack, and your Python cheat sheet out. And let's quiet down, please. Focus. Yeah, we're going over the next Python quiz, or the very first Python quiz, which is the next quiz in this class. So you have that big stack of all the practice problems, and you have the Python cheat sheet. You'll want to have both of those out for today. Often what happens for students in this class is the first quiz is easier for students than the second quiz by a lot, especially students who have no previous background in either Python or other languages like Java, C++, or R, any of those sorts of non-HTML programming languages. This is a very different way of thinking. And one of the hints that this quiz is going to be maybe much harder than the previous quiz, the quiz we took today, is that there's not just like 10 practice problems that I have for you, but if you go to the end, there's 42 practice problems. So there's just a lot more things going on that you have to know, a lot more possible variations. Last time, what we talked about, so looking at this Python cheat sheet over here, again, this by the end of this course, you'll know everything on this cheat sheet, all of these boxes, but not for this quiz. For this quiz, we're just going over a small number of these boxes. You're responsible for everything in this math section right here. You're responsible for everything in this Boolean logic section right here. Again, the Boolean logic is another word for what goes in the conditional of an if statement. Anything you need something true or false, that's what Boolean means. The math is for numbers. So those two blocks. We did the conditional statement. Conditional, anytime you see that word somewhere, that just means if. So we said the if, logical condition, and then the statements blocks like this. And then down here, we did the conditional loop statement. This is the while loop. And we started talking about this iterative loop statement and this integer sequences. We're going to do a very small amount of review today of those concepts, but we're really going to be pushing forward today, finishing up this quiz practice. And if any of those concepts you do want review on or don't feel like you're 100% comfortable with, again, under this Python control flow in class, all of these lecture videos, if you want something to watch, or the link to the Automate the Boring Stuff textbook, if you want something to read, those are how to get the right sort of review of all that material. Any questions about anything before we get started? Okay. So we're going to be jumping over here to Python Tutor in a second, but before we do that, I'm going to go back to VS Code and do a little bit more stuff in VS Code than we did last time. Hopefully more people have Python more installed now and follow along with a little bit more of the things. So again, Python, when you're actually going to be writing Python, working on any of the projects in this class, you'll always be putting it into VS Code. The purpose of Python Tutor is just to help you understand some existing Python, but VS Code is for actually writing your Python code. And when you have a file, as long as it ends in .py, that makes it a Python file. That'll tell VS Code to put this triangle button up here at the top, which you can click, and it will run things down here. And whenever you have your print statements, like I have print hello world up here, it says hello world right there. And then at the very end, print z, it prints out what the value of this z variable is right here. It also has a bunch of other stuff inside of here, and we're going to start sort of talking about that other stuff. We're going to see, so we've seen two ways now of running Python. You can do it directly in VS Code by pressing this triangle button, or you can do it inside of Python Tutor. Now we're going to see a third way, which is called interactive Python. And interactive Python is another way for helping you just sort of learn about what Python is doing and experiment with things and play around with things in an easy way. Using interactive Python, once you get into it, is easy, but actually getting into it can be a little bit hard for depending on your computer's setup. The way that will always work to get into it is there is this really long line. Every time you press the triangle button on your computer, Python is going to output some really long line of stuff, and then it will have the output of your Python code. And then it will have something like a blank-ish line down here. This thing right here is called the prompt. The prompt is prompting you, asking you to type something in. And when you press the triangle button up here, VS Code automatically types in all of this stuff right here for you. What you want to do is figure out what the prompt is on your computer. Mine is color-coded. Yours probably is not. Yours is probably all black and white. But because mine is color-coded, it's easy for me to see that this and this right here match exactly. And what you need to do is find on the big long line that appeared when you press the triangle button, what's the thing that matches exactly whatever your prompt happens to be, which again is going to be different on everybody's computer. Then after that, there'll be something that is a big long thing that ends in Python 3. And you just want to copy and paste that right here. And you do that, you hit enter, and you're now in interactive Python mode. The difference between the interactive Python and the non-interactive Python is that now we can interact with Python. If you have successfully entered interactive Python mode, then your prompt, the thing down here that's asking you, prompting you to type in something, is going to have this triple greater than sign, and this will be the same for everybody. The triple greater than sign is the same for everybody. Once you're in interactive Python, this is exactly what it will look like, no matter what your computer is set up as. And at this point, you can type in Python, and it will evaluate it for you directly and tell you what it's equal to. So if I want to do some like simple math, 2 + 3, hit enter, it'll tell me 5. If I want to do something more complicated, which we will, let's see, we'll do more complicated math, like 3 + 4 divided by 7. Put all that in parentheses, 22 times that, and then a nice raised to the power of 7 right here. And we get some nice thing like that. So whatever math formulas or Python things you want to experiment with, you can easily do that inside of interactive Python. And if you can type in a math formula and you're getting some sort of answer out as a result, you know that you're in interactive Python. Any questions about that? Yes.
So is this the same as that shell program, or is it the other one that they use in the videos as well? Because I remember they have the interactive section and the non-interactive.
Yeah, in the videos, he has this idle environment that has sort of a left-hand screen where he's typing stuff in. That left-hand screen where he's typing like the files is like this up here, and then the interactive one on the right-hand side is like this thing down here. Yeah, great question. Okay, so what we're going to use interactive Python for is to explore in a little bit more detail about these for loops. So last time where we stopped was, where we go, quiz practice right here. We were doing problem 13 and 14 where we saw these for loops. And the difference, one of the differences between a for loop and something like an if statement or a while loop is that a for loop has no condition inside of it. Over here on the right, there's nothing like involving ands or ors or equals or trues or falses. Instead, the for loop always has the format of for some variable name in some range of a number. And we want to figure out, like, how can I easily figure out what are the numbers that correspond to some particular range, like range of 5? Well, we had one way that we looked at. We looked at the cheat sheets, this cheat sheet here, and we go down to integer sequences down here, and range of 5 happens to already be on the cheat sheet. Exactly. It says range 5 corresponds to 0, 1, 2, 3, 4. Again, the semantics of range, what it means when you put a number here is it's going to give you the number 0 followed by every number up to not including the number that you type in right here. In interactive Python, we can visualize that directly rather than having to maybe remember exactly what the rule is. One thing we might try to do is type in range 5 like this, directly, range 5, hit enter. And this is sort of the not a very helpful output that we're getting from range 5. But something that you can do to get helpful output is you do list range 5 like this, and this will actually give you all of the numbers associated with that range 5. Here we get the 0, 1, 2, 3, 4. And if we come back over to the cheat sheet, look at range 5, it has the 0, 1, 2, 3, 4. The next thing on the cheat sheet, range 3, 8. If we do range of 3, 8 by itself, not super helpful. But if we use this list function, list of range of 3, 8, then it'll actually tell me what those numbers are. And so here I've done that for the exact same numbers in the cheat sheet. So maybe not super helpful. But now if I wanted to do maybe something different, like what is 6 to 9? Okay, that gives me that. What happens if I use a smaller number on the right-hand side than the left-hand side, like 6 to 4? It doesn't give me any numbers out. So you can experiment with this to get a better prediction about how this range function is going to behave, what numbers it's going to give you, so you know what numbers your for loop is going to go over. The details about why all that's doing what it's doing is not something that you need to know yet. It's sort of like when you are first learning Spanish, whatever foreign language that you have learned, you always have to just sort of start memorizing phrases, and then eventually you learn all the grammar concepts about why things are composed the way they are. We'll get to all that, but at this point, this is just a very useful pattern to understand the ranges, which will help us understand the for loops.
So if you're using a for loop, can you refer to I inside the for loop as a number?
Yeah, so let's talk a little bit more now about exactly the for loop. And let's do it in Python tutor. So up here, I'll do for I in range 10, and then print I equals, comma, I, like that. And then, so anytime you're in Python tutor, when you're at this screen where you can type stuff in, you type in the Python code that you want to run, then you press the visualize execution. Takes you to this screen with your code on the left, which you can no longer edit, and you have your output and your internal variables over here under the frames and objects. And now you press the next button, and it walks through the code one step at a time, executing the code. I didn't use these first and last buttons last time, but if you press last, it'll just execute everything and show you the final result. If you press first, it'll take you all the way back to the beginning of like nothing's happened at all. And so in this for loop, every time you go inside of it, you can see right now under this frames, there is no variable I. But as soon as I press this next button right here, then this variable I gets created the very first time that I go inside of this for loop. And the first time that I go inside this for loop, its value is set equal to 0. Why is its value set equal to 0? Because the very first number in range of 10 is 0. If I come back over to interactive Python and type list of range of 10 like that, we can see that the first number is 0, the last number is 9. It's going to go over each one of these numbers in turn. And then because this I variable has now been introduced under this global frames box over here, that means that I can refer to it however I want, just like normal Python code. Let's call this evaluating the variable I when we substitute this number over here and then print out the result. So I'll press the next button, and you can see that it printed out I equals 0 because that's what I happen to be in the global frame. The red arrow again is where the current line that I'm on, the line that I'm going to execute next. So I'm going to re-execute this for loop up here, press the next button, and now it'll go, I will be the very next number, it'll be the 1. And so when I print out this right here, next, we'll get the I equals 1. And then so on for each one of those numbers in that list that was being printed out in the interactive Python, all the way from 0 to 9. Good question. Any other questions about this code right here? Okay, so I'm going to jump back over to our practice quiz, and let's take a look at number 15 down here, getting things a little bit more complicated. This code, so total, is that 42 for I in range? Somebody shout out the numbers for me. Well, the numbers from the quiz. 10, 10, 15, 1. And then down here, it said that total percent equals I. Total percent equals I. And then just printing total, print total equals, comma, total like that. Does that look like what the problem looks like? Okay. One of the skills that is going to separate, well, that does separate very experienced programmers from not very experienced programmers is just being able to look at something like two pieces of code in two different locations and finding the differences between them. So this is trying to help get you practice with that, of being able to look up here at the screen, look at your paper, finding subtle differences in those in that code that I've written. So here, in order to understand this, first we're going to start by understanding what are the actual numbers that are going to get returned by this range. And there's two ways, again, that we have of doing this. The first is going over to our, here it is, the Python cheat sheet. We haven't seen a range with 3 numbers yet. So a 3-number range, what does that do? Well, it's a little bit hard to maybe tell from this if you don't already know, but it starts at the first number, goes up to not including the second number, and then rather than going by 1 each time, the step size is whatever the third number is. So here, 2, 12, 3 goes to 5 because 5 is 2 plus 3, then 8 because 8 is 5 plus 3, and then to 11. We never hit 12 because when we add 3 to 11, we get 14. That's bigger, so we stop. 2, 5, 8, 11 for that example. Let's come back over to our interactive Python, and it was list of range of, what were the numbers? 10, 15, 1, like that. And so here it starts at 10, goes up to not including 15, and the difference between each number is 1. It goes by 1 each time. If we were to change that to a 2 at the very last one, then it would go by 2 each time, 10, 12, 14. But the problem specifically is using 1. Yes?
If you're writing code, would you not want to have the redundant, well, the 1 would be useless. When you're writing, would you include the 1 or would you just leave it off?
Question is about when you're writing code, like, is it better to say range 10, 15 or better to say range 10, 15, comma 1? The answer is that for this class, it's not going to matter. That you're never going to be graded on things like style. You're always going to be graded on like whether something actually works or doesn't work. And so you should always do whatever makes the most sense to you. The vast majority of Python programmers would not want to have this 1 here, would want to use the fewest number of keystrokes and text possible, because that's the generally the easiest to understand. The less things there are, the fewer things there are that you need to understand. So it's here just for illustrative purposes in the quiz. You do need to be able to read it when you see other people doing it, but most people would write it like that, and it's the exact same thing. Okay, so now visualizing that execution, walking through it. Here, the total variable got created on line 1 right there, and now stepping through it, I starts off as being equal to 10. And here, one of the common ways, very common ways that students miss points on this first Python quiz is just making very, very simple mathematical mistakes. So last time I told you that that I wasn't going to tell you what the percent sign does, that I wanted you to look it up. Hopefully you've done that. And the percent sign, what it does is it actually computes the remainder of something. So if we come back over to our interactive Python and we want to experiment with like figuring out what the percent sign does, interactive Python, a great way to experiment with that. We do something like 3% 2. What's 3 divided by 2? What's the remainder of that? The answer is 1. 4% 5. 4 divided by 5 is 0. Then with a remainder of 4, so that's a 4 right there. Very, very common for students on the quiz to see something like this, see something like 4 divided by 5, what's the remainder? And in your head, compute 5 divided by 4, what's the remainder? Guarantee that like 10 people will miss a point on the quiz on Wednesday because of getting this this math backwards. That always happens. So make sure that you focus on exactly what that math is trying to do. Anytime you see an operator that has a math operator plus the equal sign, this is what we call syntactic sugar. And it exactly means that, so percent equals means total percent. That this is a very common pattern saying some variable is equal to itself with a math operator applied to it. And so rather than writing it out the full way, you can say percent equals. But so this is actually the same exact code right here. This is what we're computing. Total equals total percent I. So 42. What is 42% 10? Somebody shout it out. 2. Yeah, actually. So here we're on line 3. And so here we have 42 as total getting substituted right here. Percent I doing the division by 10. What's the remainder? Hit next. You can see that the 2 is stored in total. And now 2 is just going to stay in total the rest of the time. And so at the very end, this is not affecting anything, printing out total right up here. Any questions about the for loops? Yes.
So the reason you added the total this time, was it just to show that it's the same thing? Like doing the total equals total percent I?
So the question is, in this code here, why did I change it? That it was originally written like this. Yeah, I just changed it just to show that it's the same thing. On your quiz, if you want to like write a note, like you see these math operators write a note saying like cross out that line and write total equals total percent I. That's a 100% okay thing to do. You just need to somehow be aware that these sort of math equals operators, what they do. Yes.
So like, but if you, I know it's 10 with the remainder of 2, but then once you move down the range, why does the total not change?
Yeah, so the question is, okay, so we had 42% I, percent 10, 42 divided by 10 is 4 with a remainder of 2. Next. And up here, now total is equal to 2. I is equal to 11 now when we go on the second iteration of this for loop. 2 divided by 11 is 0 with a remainder of 2. So total percent 11, 2% 11 is going to give me 2. If I have 2% 11 right here, do that, then that value evaluates to 2. And so it just so happens that total already has 2 inside of it. But if it didn't have 2 inside of it, if it had something else, it would update it. But because we're taking the remainder of something bigger than the total number, it's always going to stay constant. It's always, the I number is always going to divide into it 0 times, with the remainder just being what the number itself is.
So it replaces the value of the total.
Yeah, so let's try changing this to a plus equals. Visualize that execution. And we'll step through. So total plus equals I, 42 plus I, 10 will get me 52. As you're working through Python Tutor, a good habit is to always try to predict what is each one of these lines going to do. So now for I in range 10, I is currently at 10. What's the next value of I going to be? Somebody shout it out. Based on this range, after 10, what's the next number going to be? 11. And so let's press next, and we were correct. We got 11. So now we have total plus equals I. When I press next right here, it's going to evaluate this line, adding I onto total and storing the results in total. So somebody shout out, everybody shout out, what is the value of total going to be after I press next? 63, yes. So I press next, and it goes to 63, adds that 11 to the to what was previously 52. And so now with this math operator, it has actual math to do each time, some actual computations. The previous one just happened to it just happened to give you the same value every time. When I am evaluating code like this, like thinking through it mentally, and I see something like this, I see a pattern that's going on, that like this total value is never changing anymore, then if I can justify to myself, yeah, that's always going to keep going, then I will stop walking through the for loop and just know that total is going to be the same. Since this only had, I don't know, 5 iterations inside of it, that's not too big of a deal. You could manually go through all of those. But if this was something bigger, like 1500, then actually stepping through all of that so many times is way, way too many. Just realizing, okay, total's not changing because this math operator doesn't actually do anything anymore. And so stop evaluating that. Let's just jump to the end. Okay, so that's everything for us to talk about for loops by themselves. Problem 17, so jumping ahead a little bit. Now we're combining for loops with if statements, combining all these different operators together, all these different control structures together. And so we have to walk through this and figure out exactly what it's going to try to do. So this code, was it result? What did the value of result start out? Somebody shout it out. 1. And then for I in range, what was the number? 5. It was if I less than 3, then I times equals 1. Else.
Isn't it result times equal?
Thank you. Result times equals 1 else. Result times equals, is it -1 like that? Print result equals comma results. Does that look the same? Okay. Visualize that execution. And now, so we've talked about for loops, we've talked about if statements. They just work together like you might expect them to do, always going one line at a time. So the very first line here, press next, get results, create this new variable over here, result, has the value 1 inside of it. Now we go to the very first time we hit this for loop on line 2. We know we're on line 2 because the red arrow is right here. When we evaluate this line, so by pressing next, we evaluate this line. That's going to create this I variable starting at the very beginning of this range. Range 5 goes 0, 1, 2, 3, 4. So we're going to start at 0. Inside the for loop, these lines right here are called the body of the for loop. Anything that's indented after one of these control structures, like the for or the if, we call this the body of that control structure. So lines 3 through 6 right here, these are the body of the for loop on line 2. And the very first statement, the very first line on the body of this for loop is this if statement right here. The condition of the if statement, the I less than 3, that's what we have to evaluate for truthiness or falsiness. Again, not going to talk about truthiness, falsiness the rest of the class, but it's another common way for students to miss points on the quiz next week is by not understanding the difference between truthiness and falsiness and true and false. So make sure to watch the videos or read the textbook on those sections. Here we have if I less than 3, I is 0. 0 is in fact less than 3, so that is a true statement. When you have an if statement and you do the true thing, you go down here and do the body of the if statement. So I will press next and come down here, do this body. The star is times 1, star equals, multiply result itself by 1. 1 times 1 stays as 1. So I press next, and it's going to come back up here, keeping result as 1. That's the whole contents of the for loop. I don't do this else. I don't do this line down here because the if statement right here evaluated it true, and you never do both the body of the if statement and the body of the else statement. You only do exactly one of those. You can never do both. So since I did this one, I do not do this. Ignore these lines right here. Back up to the top, for loop coming in, I equals 1. 1 is still less than 3, so multiply by 1. 2 is still less than 3, multiply by 1. Back up here. I equals 3. Another common way to miss points is that when you see this less than sign, it does not mean less than or equal to. It means actually less than. 3 is not less than 3. 3 is equal to 3. So when I press next right here, I less than 3, that'll evaluate to false. And I'm going to go down here inside the else statement, jumping down here. Now we're in the body of the else statement, line 6. Previously, we only did this one up here. Now we're doing this one down here. Line 6 multiplies by -1 instead of +1. So this 3 will become a -3. Oops, sorry, the result, the 1 in result became a -1. This is result times equal, not I times equal. Keep running through that. And the else statement is always going to be what we're doing now. I is always going to be not less than 3. So we keep doing that. Times -1 again. We're at the I equals 4. This is the very last element in our range. So when I press next, we're going to jump past the for loop, evaluating the line down here and printing out result equals 1. Question?
I noticed since we're talking about if and else statements, I noticed there's no elifs. Are we gonna have to know those as well?
Question is, on the quiz, there's no elif statements. The videos talk about what if you have a big chain of ifs and elses that you might want to use. And for your coding, when you're actually writing code, that will make things a lot easier. For this first quiz, though, there will not be a elif statements, just if and else. Good questions. Any other questions on just, the main thing to understand here is how to walk through this using Python Tutor so that you can look at the quiz on your own time and check your results and understand why your results are correct or why what you thought was going on is not in fact going on. So the main thing to make sure you understand is how to interpret this Python Tutor output and know what's going on. Let's see, how many people before this class have done some sort of programming involving for loops, if statements, those sorts of things? About half the class-ish, a little bit more, okay. Let's see, so the next thing that we're going to is where, so most students, whether, if you previously had some background, find up to this to be like maybe okay. But then the next parts, we're going to start talking about functions, and that's where things, one of the places people fall off the train. So if you're zoning out right now, now's a good time to pay attention for another 5 minutes. We're going to jump down to problem number 23. Here, question. Great.
So that last problem when I equals 3, you took the else statement.
Question is on this right here, when I equals 3, I is not less than 3, 3 is not less than 3, so 3 less than 3 evaluates to false, so you do the else statement, yes. Yeah, so let's just review what are some of the common ways that students miss points on quizzes. Very common way is not evaluating your less thans and greater thans correctly because you think that less than means less than or equal to. It means less than and not equal to. So 3 is not less than 3. 3 is equal to 3. Other common way of making mistakes is just like trivial math errors of especially with the remainders and the integer division, getting like the order backwards of how you're doing those things. And then the third way that students often make mistakes is just using the wrong numbers in the range. So making sure that those 3 things always like coming back to and checking your work on that. And those are sort of like not conceptual things about how students make mistakes. But here's a very common conceptual thing about how students make mistakes. And this is true both for students who have no previous background programming and students who have lots of background programming. And that's how these functions work. Anytime you see this DEF keyword, DEF stands for definition. This defines a function. And so we're going to walk through exactly what's going on in this code right here. I'm going to do some modifications to it to help us understand what's going on in problem 23, and that's going to cover like the next 7 or 8 problems. So it's x equals 5, x equals 5, def foo, like that. Print hello, return 1, x plus equals foo, print x equals comma x. Did I get it right? Any mistakes? Okay, so let's visualize this execution, and we're gonna pay extra attention over here to this bottom right corner with this frames and this objects as I'm stepping through the code over here on the left. So let's press this next button, x equals 5. Okay, we've seen that before. This x variable got created. This value is over or equal to 5. Now let's see what happens when I do this line 2 right here. Again, the red arrow means the line that's going to be executed when I press the next button. So I press next, and you notice that it jumped all the way over this entire, we call this the body of the function. This is the name of the function foo right here. We jump all the way over the body of this function, not evaluating, not executing any of the code inside of here. You'll see this foo variable down here appeared. So whatever the name of this function is, whatever comes to the right of the def is the name of the function. I call it foo, common programming name. And over here, there's this object of foo with these parentheses that just tells us that this variable right here is in fact a function. When I do this x plus equals foo, it's going to first do what we call evaluate this foo function. Whenever you see the name of a function, so here's the name of the function. We know it's a function because it has this arrow over here. When you see this and you have the parentheses next to it, it's going to next go inside and actually run this function. So we're on line 5 right now. The red arrow's on line 5. So when I press next, it's going to jump back up here to this def foo function. The previous line, notice the green arrow right here. The previous line is this one right here. So previous line, green arrow 5, red arrow 2. I'm going to go back a little bit so that we can see what happened at the beginning. Press next right here. Here we have the red arrow on 2 and the green arrow at 1. Because it's like this, it means that I'm not going to execute anything inside this function. I press next, and we'll see the red arrow is going to jump all the way down to 5. Now, press next. There we go. The red arrow is on 2, but the green arrow is on 5. On 5, there was this called a function call or a function invocation or the usage of a function. And now it's actually going to go inside of the function call because the green arrow line, there we go. The green arrow line was on a function call, something that had the name of the function with parentheses next to it. So we're going to go inside the function next. Now that we're inside the function, we have this print hello right here. Run that, and we'll see that hello actually gets output. Down here, we have this return 1 value. The return 1 means that whatever the location of that function over here was, we're going to substitute this value 1 inside right here. So this will be like x plus equals 1.
Whatever the location of the function?
Yes. So here, if we're on line 3, we're going to run line 3. Notice there's no output over here yet. So I press next. We get the output over here. Now the red arrow's on line 4. This special thing about line 4 is that it has this keyword return. Return means that whatever this value is over here, this 1, is going to get substituted right here where we have foo. Python Tutor is going to break that up for us. So I'm going to press next. Notice the red arrow is currently on return 1 like this. I'm going to press next. And so it had this foo over here. This foo, I didn't mention it before, but this box, this blue box right here, foo, got created as soon as we entered the function body. So right now I'm on line 5, running line 5, press next, come up here. Now the red arrow is on line 2. We're going inside the function body this time because we invoked the foo function. And so this blue box down here got created. Now I press next. We're still inside this. Press next again. We're at the return statement, have not yet evaluated the return statement. Let's evaluate the return statement, pressing next. And you can see that it tells us down here the return value is 1. In this case, there was no computations to do, so we already knew the return value was 1. But if there were some sort of math right here, it would compute that math and tell us right here what that math is going to be. Now you can see that the red and the green arrow right here are, it's like kind of like they're on the same line because all it did was evaluate this. it evaluated this statement for us, but it didn't actually take us back to this statement right here. So right now, we've done the foo function, done this print, done the return. We have this return value of 1. We're going to substitute 1 for this value right here, x plus equals 1. And so we get the 6. Now when we print x equals, we get the x equals 6. Any questions about how that worked, especially the visualizations going on in Python Tutor? Yes.
I got a little confused with what return one was again. So like.
So let's, yeah, so question is confused about what exactly does return 1 do? And so let's try some variants on this to help us better grasp what's going on. So let's try return 12 as a simple variant that's just a little bit different. Come back here again, skip over the function the first time we do it. Here we have a function with parentheses. So we go inside the function, we execute, evaluate the function, print hello right here. You can see hello appeared up here. And now we're on to the return 12 line. I press next, and the 12 value gets substituted for the return value right here. The next thing that I'm going to execute is line 5 right here, because that's where I came from. And when I do line 5 right here, this foo is going to get substituted with whatever the return value of this foo function call is. So 12 right here, this is going to get, it's like deleted, put a 12 right here, x plus equals 12. So x is currently 5, 5 plus 12 is 17. And so now x has 17 in it, run it, 17 stored up here. Let's edit this one more time and change this so that it has just a little bit of math going on, like 2 times 4. Visualize that execution. Step through, back to the return line right here, 2 times 4. As soon as I hit the next right here, it evaluated that 2 times 4, that 8, put that 8 right here so that I can see what was the computation here, what was the result of this computation. Visualizes that for us right here as the 8, and now it's going to go substitute that 8 right here. 5 plus 8 is 13, and then print x equals right there, x equals 13. Yes.
What would be the correct answer?
Question is, on the quiz, would the correct answer include the hello? And the answer is yes. On the quiz, your output should match exactly what's up here. Yeah. Whether you have the spaces correct or not is not important, but you have to know that this hello actually did in fact get printed. I'm going to do some more variations off that, and we'll see why it's important that you know that the hello did in fact get printed. So the first variation, let's see, this is what it was before. Let's repeat this foo 3 times like this. Visualize that execution. And now when we step through this, so we'll skip over that function call right there, x plus equals foo right here. We'll go inside this function right here next and print out that hello, compute that 8, and substitute that 8 into the x value that we did on line 5 right here. But now we don't go on to line 6, and we're going to do that foo again. Run that, and we print out hello again because we're doing this foo value again. And do it again. And so because we had these 3 different function calls right here, this hello is being printed out 3 different times. And so that's why for the purposes of the quiz, it will be important to write out all of the print statements so that we can verify that you knew, in this case, how many times this function got called and that this did in fact run. Before I take questions, I want to do one more variant on this, maybe 2 slight variants. The first is that we'll see that if we don't have like an x plus equals, we just have the function call by itself, then it's still going to run the foo function, still going to print the results. So we're still going to print hello right here. But then when we get the return 2 times 8, still compute the 8 value, but we're not doing with the 8 anything with the 8 value that's not being assigned to a variable in any way. So the x value doesn't change. The difference between this line and what we had before is there was an x plus equals before, so the x value changed. Now there's no x plus equals, so we still run this function, but we don't do anything with the return result. The print result still gets printed, but the return result, nothing happens. Keep running this, and you can see that still hello gets printed 5 times, but now the x doesn't change at all. Getting back to the hello, what happens if I forget these parentheses? On the quiz, students tend to do good about what's going to happen right now. But when you're actually doing your own coding, this is one of the most common mistakes for students to make with the code that you're writing yourself, is to forget the parentheses. And so we're going to see what happens now when you don't have the parentheses. And in a lot of programming languages, this would be like an actual error. If you've used C, C++, Java before, this would not be valid. It would give you error messages if you forget the parentheses. In Python, you're not going to get an error message. It's just going to go on to the next line. So here we're on line 5 right now. That's what we're going to evaluate next. When we had the parentheses, we went inside this function definition, printed hello. When we don't have the parentheses, then we just do nothing. We don't go inside the function definition. And at the end, print the value of x. So this is one of the traps to look out for on the quiz is if you see something that looks like it's the name of the function up here, only go inside and actually do the stuff in the function if it has the parentheses. Okay, there was a lot of things that we just talked about. Any questions on, yes?
I tested it out, so I put print hello after the return, and that did not pop, that did not show on the output.
Yeah, great question. So let's change this back to our first problem, like this, x plus equals. And the question is, what happens if, let's see, I'm going to put hello here, and we'll print goodbye here like that. And we'll see what happens. And so we'll press next, still jump over this entire function body down to this x plus equals foo down here, and press next. We have parentheses this time around our function, after our function. So we're going to go inside the body of our function. And then we evaluate this print hello right here. And so when we do that, we'll see that hello does in fact appear up here. And then down here, line 4, return 2 times 4. As soon as you see this return, that means, so the reason why we chose this word return to mean what it means is because we stopped the function and we return to where we were outside of the function that called the function. So we're on line 4 right now, has return 2 times 4. We're going to execute this line, press next, and you can see that down here we now have a return value equal to 8. And we're going to skip everything that might be coming after this function in the code down here. And we're going to go back to where the function was actually called. Press next like that. So we skipped line 5. You can see that goodbye is not printed up here. We did evaluate the plus equals though, put this 8, added it to 5, got 13 here in the x. And now, so when we do the very last statement, the print will get x equals 13. So return means not only does this number, whatever this computation is, not only does it get replaced back here, but we say that the control flow also gets moved back here, and whatever other code you have in your function doesn't get executed. Yes?
So you would say that print goodbye is still in the body, but it would just not be of the food function I defined, but you would execute it.
Exactly. So this print goodbye is still in the body of the foo function. Whether something's in the body of something else is purely what we would say a syntactic thing. It's purely a matter of like, is it indented or not indented? Whether something is in the body is only a matter of whether there are spaces in front of it or not. Whether something gets executed or not is a much more complicated matter. And in this case, this line right here does not get executed. Good question so far. Go ahead.
So,
Yeah.
One more question.
Yeah.
If I put goodbye in unindented, it's ended up showing up first before anything else.
Yeah, so now the question is, here we have goodbye not indented. What exactly is going on here? And so now if I press next, what we know, the reason why we know things are in the body of this function, they're associated with this function, is because they're indented like this. Print goodbye is not indented. So here on the very first time we execute this line, the very first time that we execute line 2, we're not calling this function. So we're skipping the entire body. And because print goodbye is not indented, it is not in the body of the function. We're going to jump down and immediately go to the next line that is not in the body. In this case, it's line 5 right here. Execute line 5, prints goodbye right here, goes on to line 6. Line 6 does have a function call right here. Notice that now this function call is not next to the invocation, the definition of the function. We are invoking it here, we are defining it here, and there is stuff in between, and that's totally okay. And we run through this, return 2 times 4, get that 8 number, and the 8, like we're on line 4 now, but we're not going to line 5 next because when we do return, we go to the place that called the function. So we press next, computes that value 8, press next again, computes the value of that function, puts it there, 8 plus 5 is 13, stores it in X and runs it. So it's yeah, critical that you understand like what is and is not inside the body of a function or inside the body of a for loop or if statement, all of these things, so that you know exactly like when each of these things is going to get executed or if it's going to get executed. Henry?
So if you just had a foo, like let's just say line 7 became line 8, and you got a foo in there, that would print goodbye if goodbye was part of the definition of foo. Return to it.
Yeah, so here I'm just going to press the last. You can see that print goodbye not contained in the definition of foo. So goodbye only getting printed once, and it's getting printed at the very beginning of our statement up here because it happens before any function calls. And then the question is, if we indented this, moved the print goodbye inside the function definition, then now I'm going to press last, run the whole thing. This line here never can get executed because it has the return statement in front of it. And so we just have hellos being printed. Do one more variant of this, move this return after this. So hello, goodbye, then return. Visualize this execution. Press the last button, and you see it says hello, goodbye, because here under foo, walk through it, start from the beginning, walk through it slower. So here we're calling the foo. Now we're doing it the very first time from line 6 right here, printing hello, print goodbye, return back to line 6, then go down to line 7, invoke the function again up here, print hello, print goodbye, return again, back down to line 7. Don't do anything with that return value because it's not part of an assignment or an expression in any way. Go on to line 8 and x equals 13. Print that out. Great questions. Answer?
My question was that.
Cool. Yes.
Could we do something with line 6, for example, x plus equal to function times 2?
Yes. So what if we have some more computations down here? The answer is you can have arbitrary computations, and it will first do the substitution and then evaluate the times 2. This is sort of related to like order of operations, that function evaluation is always the most important order of operation, that we don't even know what this number is yet, so we can't do the multiplication before we do this function call right here. So it did the function call right there. Now the return value is 8. Now it's going to, it'll do it all in one step for us. It did the 8 times the 2 right here, giving us the 16, and then putting that 16 plus 5 to 21. Real quick, we have about 1 minute left. I just want to do some more variations on this. You can pass variables inside here, pass a y like this, and now if I put a number right here, the function will have access to that y variable. So def foo y, x plus equals foo times 3. When I invoke this function call right here, coming back up, you'll notice that it created this variable y automatically with this value 3 inside of it. Come down here, do the substitution. 3 times 4 will give us 12. And working out the math, it gives us 29. At this point, we've covered everything that you need for the for the quiz. You should be able to do all of those problems. Some of the latter ones are going to be pretty tricky. Definitely require paying a lot of attention. But strongly recommend you get started on working on those. We'll have our lab on Friday, and so I'll see you all then. Thank you.